Good evening, folks. My name is Sam, and I will be explaining to you my strategy about how to tackle creating a solution for tic-tac-toe problem. And we will be using minimax algorithm, which tackles this problem to come up with a system that plays perfectly, managing to win every match, and if not, then finishing the game with a draw match. So moving on to the simple algorithm we have here, the pseudocode shows that if check the game is over and check the score for x, we will be playing and solving for playing first, and that is the first game starts with x in any of the position of 9 positions of the tic-tac-toe uh, play spaces. And else, if the game is not over, we need to get a full list of possible game states for every next move possible. So at the very top, there will be 8 possible moves next for each game state that we started on. So next, so after creating the possible game states, we'll create a score list, and in this score list will be filled up with mini-max results, which I will be detailing on afterwards. And that is next step is for each instance and states that is created for possible games, we need to add the mini-max result of that state or that possible move. That possible move's minimax result will be added to the scores list. So each state will have a minimax result, and that will be saved in the scores list. And if it is X's turn, we return the max score from the score list, and we'll choose the state that returns the max score. And if it's O's turn, then O needs to win. So that would mean that we need to return the minimum result from the scores list. And the state that sponsors the minimum result will either be minus 10 or 0. In this case, 0 being draw and minus 10 being X losing the match and O winning the match by securing a combination of 3 diagonally, row wise or column wise. And that is the pseudocode. So it's either max score or minimum score, depending on if it's X turn or O's turn that they're going to take. So I'll explain it to you much more clearly with a visual representation of a game that is ending in 3 moves. And if you look at this one right here, it is an opportunity for X to move next, and there are 3 choices for X to move. And out of this, we find that in this state, the max value is plus 10 because there is a combination right here formed, and that is a sure victory, and therefore it is registered as a plus 10. And obviously the system will recognize that by understanding the whole states and comparing the score lists, and select this as the best option. Not just that, because the function is running, they will search extensively throughout the depths to understand the possible states. And these 2 states, after X has been filled into these gaps, we find that other moves that is possible for these states when O is moving next is either here or here for this one, which leads to X winning and X drawing here, and the O can secure a draw if they move on this way. And they are able to understand that they can go this way and help and hinder X plus from winning the game. And it is possible because of the minimax laws that is happening and functioning in each node. So we have different depths at the last 3 moves. All of this can be shown as a tree, a subtree right here. And beginning at first, the node is neutral, they don't know where to go, and the first x is moving, x is the next move now, and we see that in this move right here, x can win by having a maximum point of plus 10. X is moving, so we will be focusing on getting the maximum value, and the maximum value here is draw versus win. They will obviously choose the win condition. And if that didn't happen, if some other opponent was playing, like if it was a human playing, and they chose x to play somewhere else on the last two other options where there could be a possibility of draw and not winning immediately like this, what is going to happen is that when it is turn for O to play next, there are two options that will lead to X winning and O drawing. Therefore, plus or minus 0, plus or minus 0. These are all numbers. There's no O here. 0 or 10. So they will obviously choose the choice where it will lead to them drawing the match. There's inevitable. And because the minimum function is working, the O will be pushed upwards to the nodes. Right here, the 0 will be pushed upwards to the nodes, which is signaling the that they can draw the minimum function of the row. Minimum function applied in the row. The 0 will be pushed up to the node, and they will understand which action needs to be taken so that they can have the ideal outcome, that is drawing the match. And if that didn't happen, they chose some other option. If it was not a computer but just perfectly programmed by an algorithm like we are doing, if that is not working here, maybe a human is making this decision of where to put the O. They might choose somewhere where it could land to X winning, and then you see the same cycle can be repeated in the max value, where they will be choosing the best option, but sadly at the very end there is only one gap to add the X, and that gap will be leading in these two instances to victory. So it's pretty much game over when you make that mistake here as a human, and the algorithm can make best decisions out of these instances and guide themselves towards victory because of the coding of minimax, minimum and max, because nothing else, just a simple system, is able to hunt for the best possible outcome and come to victory at the end. So that is my explanation of this tree and this algorithm as a solution for the tic-tac-toe problem. Thank you.